Bonding. You know, a lot of students just forget that bonding comes up on paper 2 and paper 1. So hydrogen bonding is when there's an attraction between an electron deficient hydrogen atom of one molecule and a lone pair of electrons on an NOF atom on a neighboring molecule. And basically, non-polar molecules have small temporary dipoles. Iodine atoms are held in pairs by strong covalent bonds forming iodine molecules. The molecules are held in molecular lattice by weak van der Waals forces. Intermolecular forces are much weaker than covalent ionic and metallic. Molecules of permanent dipoles, weak electrostatic force of attraction between delta positive and delta negative charge is on neighboring molecules. Yeah, I didn't ever ask you that. Difference in electronegativity between two atoms in a polar bond causes a permanent dipole, and polar molecules have permanent dipole forces. Definition of a dipole. A difference in charge between two atoms caused by a shift in electron density in the bond. A difference in charge between two atoms caused by a shift in electron density in the bond. Charge is a non-polar molecule. Positive and negative charge spread evenly across the molecule. Two atoms of different electronegativities, the bonding electrons pull towards a more electronegative atom, therefore polar bond, and the covalent bond between two atoms of the same element are non-polar because atoms have equal electronegativity, therefore the electrons are equally attracted to both nuclei. Three key characteristics of ionic compounds: conduct electricity, high melting point, dissolve in water, and part molecule small positive charge, part molecule small negative charge. Metallic bonding. Positive metal ions attracted to delocalized negative electrons, forming a lattice of positive ions C delocalized electrons. Three key characteristics of metals: insoluble except liquid metals, strong metallic bonds. Delocalized electrons pass kinetic energy to metals, good thermal conductors. We only have to overcome the intermolecular forces that will hold the molecules together. That's one of the most important things you need to know. You don't have to break the covalent bonds. You only have to break the intermolecular forces. Molecules are held together by strong covalent bonds, and single covalent bond contains a shared pair of electrons. Structure of graphite. Again, this is GCSE stuff, so I'm actually just not going to go through this. Data of covalent bonding. Both electrons come from one atom. The NH4 plus ammonium ion form when nitrogen and ammonia donates a pair of electrons to H plus ion. Work out central atom, work out number of electrons out the shell, add 1 for every atom central atom bonded to, divided by 2 to find number of electron pairs central atom. But if it's a positive charge, you subtract 1. If it's a negative charge, you add an electron. Lone pair are the biggest, lone pair bonding pair, second biggest, bonding pair are the weakest. When liquid water cools to form ice, molecules will make more hydrogen bonds. A regular lattice structure, molecules further apart, the molecule liquid water, ice is less dense than liquid water. Again, something they would never really ask you about, so I'm going to get rid of that.